Thank you, Chairman Baird and members of the subcommittee, for this opportunity to have a rational discussion on the science of climate change. I've got a PowerPoint which we are going to bring up, and it will reinforce several of the points that have already been made on the panel this morning. And I'll say that my background is a little bit different than some of my panel members in the sense that I spent several years at the Weather Channel as their on-camera climate expert, and it was a great experience, and it was really interesting to me because when I got there, most people just assumed I was a meteorologist, so I got a lot of questions about what the 5-day forecast would be, and while I love the 5-day forecast, it was a really important opportunity to just help people understand the difference between climate and weather, the difference between climatologists and meteorologists, and the difference between weather forecasts and climate forecasts. And if you see the great quote by Mark Twain up there, he basically said it all, which is climate is what we expect, weather is what we get. And I'll say, basically, it's a lot easier to see the weather. It's a lot easier to see what we get. Climate is a statistical construct, and it's tough to see it. So our job today is to help you see it and to help you understand why the forecasts that we make for the end of this century are something that we can trust. To start out with, Mother Nature's strongest fingerprint on our climate system is the seasonal cycle. So here's a climate forecast for you. Here in D.C., it's going to be colder in January, but then it's going to warm up in July. It's a climate forecast. My grandmother could give it to you. It doesn't take a genius, but it shows you that we have an understanding of our climate system that allows us to look further into the future. The other thing that I really hope that our discussion this morning can help you understand is why our long-term forecast for the future is something that so many of us on this panel are deeply concerned about. So I'm an engineer by training. I worked on Wall Street for a little while and then decided that I was really fascinated by climate. It has a lot, it's a lot like Wall Street in many respects. It looks kind of like stock market ups and downs on various time scales. And I'll say that the tremendous variability of the climate system is fascinating to me. And this GISP-2 ice core record here that you see, focus on the last 10,000 years. The top part, which is pretty flat, that's the last 10,000 years of our climate. And what's really fascinating is that it's relatively stable. And so what drew me into climate science was this question of, to what extent does climate stability link with human civilization? Because complex human civilizations started at about 10,000 years ago, right about the same time where our climate began to become more stable. So if any of you have read the book Collapse by Jared Diamond, you'll know that civilizations have failed over time due to the inability to look out on long enough time scales and to be adaptive to our environment. Now, my next slide is more or less to just highlight the fact that, gosh, we've been studying this problem for an incredibly long time. The gentleman in the oil painting is Svante Arrhenius. He got the Nobel Prize in Chemistry in 1903 for doing the back of the envelope calculation that Dr. Neal spoke about, which is if we doubled CO2 in our atmosphere, our planet would warm roughly 8 degrees Fahrenheit. Where Arrhenius made his mistake was that he was around at the turn of the century in the 1800s, and he basically assumed that we would continue to emit fossil fuels at the 1895 rate, and so it would take 3,000 years to double. So he was wrong there, but that's where Bert Bohlin came in. Bert Bohlin actually called for the creation of the IPCC, and he did his own back-of-the-envelope calculation, which suggested that CO2 would increase by about 30% by the year 2000. That turned out to be very true. Charles David Keeling, another giant in the field of climate science, basically figured out how to measure this invisible greenhouse gas we called carbon dioxide. We wouldn't need to have this panel if we could see carbon dioxide because it's everywhere. By burning fossil fuels and through deforestation, we emit it. But he figured out a way to create and build a machine that was like an atmospheric breathalyzer that could measure CO2 in the atmosphere. And he showed, just as Bert Bohlin calculated, that we've increased our CO2 in the atmosphere by about 36% now. We're at 390 parts per million. I know that that does not sound like a lot, but because of the special chemical structure of carbon dioxide, unlike nitrogen and oxygen, which there is so much more of in our atmosphere, they have just 2 atoms. CO2 has 3, and that allows it to absorb tremendous amounts of long-wave radiation and be a great absorber of heat, and that's why our planet is essentially warming up. The other thing that Keeling was able to do was to chemically fingerprint the CO2 so that we knew that it was coming from us. Carbon comes in 3 different flavors. We call them isotopes. Fossil fuels, when they give off CO2 from burning, they have essentially no C14 because they're ancient. And so what Keeling was able to do was to say that roughly 1 out of every 4 carbon dioxide molecules in our atmosphere today was put there by us. It's our human fingerprint on the climate system. As Jerry said, we are increasing the overall temperature of our climate about 1.4 degrees Fahrenheit over the past century. How does that make its way into our weather? My experience at the Weather Channel made it very clear that we can see our weather, we experience our weather, we know what that means. But how is climate change impacting our weather? Essentially, Mark Twain's quote can now be rewritten, which is to say that climate is what we affect and weather is what gets us. So we can expect to see more extreme events, and if you talk to Warren Buffett or anyone who deals with insurance, they will tell you that if we don't take climate change into account, we are making very, very costly mistakes. We insure very, very high amounts of weather-related disasters each year. This is an example, a picture from the Nashville floods of 2010. It was considered a 1 in 1,000 year event. That probability is expected to increase more so with each passing year if we continue to emit greenhouse gases, business as usual. And just to summarize, I mean, I'm a scientist by training, and I have to say my time at the Weather Channel really, it just awed me the way our country could rally around a weather forecast. I mean, whether it was sandbagging in advance of the Red River floods or evacuating in advance of Hurricane Gustav, we know what to do with a weather forecast. I mean, it's really impressive. And the thing is, how do we figure out how to respond similarly to a climate forecast? Weather forecast is all defense. I mean, we get the information, we've got to figure out what to do. With a climate forecast, the one difference is that we have the opportunity to change it because it is just one potential future. So essentially, when we think about the future, we're talking about an increase of 10 degrees Fahrenheit by the end of the century, 3 feet of sea level rise. It's a radically different climate. And the question is, if climate change is this ultimate procrastination problem, we're in a race essentially to understand our climate forecasts and just get to the point where we can act on them. And I would just say that as a scientist, if we don't do that, that would just simply be irrational.
Thank you, Dr. Colonna. Thanks to all of our witnesses. At this point, I'll recognize myself for 5 minutes, and we'll follow in alternating order.